Welcome to this lesson on finance, present value annuities. Let's have a look at question 6. Mars Bank offers personal loans at an interest rate of 15.63% per annum, compounded twice a year. So this is biannually, twice a year. Gauss borrows 3,000 Rand and must pay 334 Rand and 93 cents every 6 months until the loan is fully repaid. How long will it take Gauss to repay the loan, and how much interest will Gauss pay for this loan? Okay, so again, we can visualize a timeline here, and because we asked for how long it'll take to pay off the loan, essentially what we're looking for is our Tn. So we have T1 or T0, T1, T2, T3, all the way up to Tn. The n is what we are interested in finding, and because we are compounding twice a year, how we will interpret this timeline is that this T0 to T1, that's going to be the first 6-month period, and then T1 to T2 is going to be the next 6-month period. So this is going to be counting in 6-month intervals. So at the end of the first period, that's 6 months gone, he's going to pay X amount, which we know is 334 Rand and 93 cents. And then T2 here is going to be, again, another amount of X, which is 334 Rand 93 cents. We just want to know how many of these twice a year payments he needs to actually make in order to pay back the 3,000 Rand that he's borrowed. So the principal amount here is 3,000 Rand. The interest rate I was given as 0.1563. Now dividing by 2, because instead of 12 months where we had 12, we're doing it twice a year, which is every 6 months. So it's divided by 2. You're doing 2 payments in the year. Just like with monthly, we did 12 payments in the year. So you're always looking at how many payments you are making in that yearly period and then dividing by that number. So if it is monthly, it is 12. If it is twice a year, then we are dividing by 2. So I'm going to go ahead and put that value into my calculator, 0.1563 divided by 2, and go shift store A. And now I can see if I click alpha A, I've got that value stored in my calculator. So we have the principal or present value amount we want to pay back. We have the interest rate. We are looking for N. We don't know that, but we have X, which is given as 334 Rand and 93 cents that he's paying every 6 months. So now the present value formula is P equals X times 1 minus 1 plus I to the negative N all over I. Now we want to solve for N, and N is in the exponents. So we're going to have to carefully deconstruct this algebraically to get the solution for N. So the first thing I'm going to do is I'm going to multiply both sides by I. So that's going to give me P times I equals X times 1 minus 1 plus I to the negative N. Then I want to get rid of this X here by dividing both sides by X. So therefore I have P times I over X equals, so those will divide and you're just left with 1 minus 1 plus I to the negative N. So remember, the goal is we want to solve for N here, and N is an exponent. So what did we learn that will help us solve exponents when we have a problem with the variable being in the exponent? Well, we had to use something called logarithms. Okay, and that's exactly what we're going to do here. So first of all, what I'm going to do is I'm going to take this negative term over here and bring it to the left-hand side, and then take this term and subtract it. So what you'll get is on the left-hand side now positive 1 plus I to the negative N equals, on the right-hand side, we still have 1 minus this term now, P times I over X. Okay, we're almost done. Now this is the entire base, 1 plus I. So if I take log of base 1 plus I on both sides, so it's going to be 1 plus I to the negative N, and then taking essentially log of this entire term, and then we're going to take log base 1 plus I of the right-hand side, which is this entire term, 1 minus P times I over X. Now the logs here, because of the same base, I'm allowed to bring the exponent down. So therefore we have negative N. Remember, your exponent is negative N equals log base 1 plus I into 1 minus Pi over X. So let's just clear this up so we have it a bit more written neatly so we can actually see what's going on here. Right, so at each algebraic step, just make sure that you're applying your exponential and logarithmic laws correctly. So far we have negative N equals the log of the base being 1 plus I of the term 1 minus pi over x. Notice I'm not doing each step by substituting the numbers and finding them because I'll get rounding off errors. So I'm trying to algebraically solve for n so I can put everything in at once. Okay, and then lastly, to get rid of that negative sign, I'm going to multiply both sides or divide both sides by -1. So I'm going to have negative log of base 1 plus I of 1 minus pi over x. Okay, so now, what are all the variables that we have? Well, we said we stored it, I think, in A. We'll check now, 0,1563 over 2. That was the value we stored in A, so let's just check. Yes. Okay, so that's the I that's going in there and over there. We've got P as 3,000 and we have our X as 334.93. So I can put all that in. So it's negative. Then what you want to press on your calculator is this log button with the base. So the base, I'm going to put brackets in there. It's going to be 1 plus I, which was A in our calculator. And then inside the arguments of the brackets, it's 1 minus a fraction. The 3,000 Rand was the principal amount times the interest, which we have as A, over X, which was 334.93. So doing all that, and I'm going to get 16 payments. So this is approximately 16 payments. But what does the 16 payments mean? It means you're making 16 payments, and all of those are going to be 6 months, 6 months. So 2 payments in a year. And if you're making 16 payments, so 16 divided by 2, that is 8 years of payments. Because remember, every year you're making 2 payments. So two payments in the first year, 2 payments in the second year, 2 payments in the third year, all the way up to the 8th year. That'll give you a total of the 16 payments that we are interpreting from this solution. Because remember, in here, when you look at the time period, it's telling you how many 6-month periods. There are 16 6-month periods. Yes, so that means 8 years in terms of this. Okay, so that's how long it'll take Gauss to repay the loan. How much interest will Gauss pay for this loan? Well, he's making 16 payments of 334 Rand and 93 cents. So effectively, he's paying 5,358 Rand and 88 cents. And I subtract that from the original 3,000 that we took out as a loan. So you paid off that. So he's paying 2,358 Rand and 88 cents interest on top of this loan. Okay, so the important part, was just identifying the correct time period. It's every 6 months. So in every 1 year, there are 2 6-month payments that are being made, and you're doing 16 of these in total. So it's going to take 8 years to pay off this loan. Right, so that's how we would do this type of question. I'll see you in the next one.